7.1 basic trig identities. These are the building blocks, the groundwork for more complicated problems. Okay, I'm just going to give you a list of identities that you have to know. Some of these you already do know. Reciprocal identities, I think you know, you just don't realize it yet. What's the reciprocal of sine? Cosine. Right. Tangent. So you already know some of these, right? Then we'll do the opposites. So cosecant, secant, and cotangent. What do you think those are? All right, 1 over sine, 1 over cosine, and 1 over tan. Those are the reciprocal identities. Like I said, those you already know. Quotient identities. Now, I've actually talked about these before as well. Tangent can be written as sine over cosine. You just use that to create the tangent graph. Cotangent, same thing. In this case, it's cosine over sine. You finding all these okay on your identity sheet? Yeah, they're all on there. Then we have what's called the Pythagorean identities. These we've probably not ever seen before. Sine squared of theta. Okay, that means you have two sines multiplied together. The sine is squared, not the theta. That's sine of theta times sine of theta. It'd be sine squared of theta. Okay, just like if I had 3x times 3x would be 3x quantity squared, right? So we got sine squared plus cosine squared equals 1. That's an identity. Tan squared of theta plus 1 equals secant squared of theta. And 1 plus cotangent squared equals cosecant squared. Then we have what's called the opposite angle sine of negative theta is equal to something. The cosine of negative theta is equal to something. question is, does the negative stay or does the negative go? For sine, it can be pulled out to the front of sine. So the sine of negative theta is equal to negative sine of theta. Cosine of negative theta becomes a positive. And that's because of the way the graphs work. Okay, sine starts at 0 and it goes off to the side. Cosine starts at 1. It kind of comes down in a mirror image off the axes, right? Okay, because it's symmetric, this negative goes away. Okay. Now I'm not going to go through tan, cotan, secant, cosecant. If you know what happens to sine and cosine, you should be able to figure out what happens to tan, cotan, secant, and cosecant. Okay? What the heck? Let's go through it. What's the reciprocal of sine? Okay, so cosecant should act pretty much the same thing as sine, right? Because we can write cosecant as 1 over sine, we put that negative out front. So cosecant of negative theta is going to be negative cosecant of theta. How about secant? What is its reciprocal? Well, we just wrote it down. Cosine. What happens to cosine? It goes away, so this one won't go away. Tangent, cotangent are a combination of the two. You've got to think a little bit on these. Tan is sine over cosine. For the sine of negative theta, the negative comes out. Cosine, it stays, or it goes away. So we have a, what's that going to be? How about cotangent? Is that going to be any different than tangent? No, because cosine over sine, you're still going to pull one negative out. So which two are the only ones that actually turn positive? Cosine and its reciprocal. All the rest keep the negative. Okay? So that's our tools. That's the basic ones. There's a lot more that we'll get into, but that's the basic ones. They have to become part of your memory. Okay? I'll think about giving you maybe a note card or maybe the identity sheet. I'll think about that for a test. But right now, that's not that many. It could be a little bit more of those. That would be a nice little quiz. Write down certain identities, opposed to reciprocal, from memory. Okay? Think about it. Let's take a look at a couple examples that we can use with these. The most important thing that we're going to do with these is simplify. We're going to simplify sine of x plus sine of x cotangent squared of x. Usually when you're asked to simplify something, it will break down to something very simple. Usually a single trig function. So we got to turn that into a single trig function. How do we do that? No, you can't combine them. They're completely different. But if you look at each term, okay, we got that one, sine of x, and we have sine of x cotangent squared of x. What do they have in common? Sine of x. So we're going to factor out a sine of x. Again, experience will help you see these things. So if I took a sine of x out here, what's left in the first term? Don't say nothing. There's always something left. Okay, well, how about we say it this way? 1 plus, this is more or less going to go away, right? There's always an understood 1 out front. 1 plus cotangent squared of x. Whatever you pull out, you can scratch out. What is 1 plus cotangent squared equal to? Again, look at your notes. You probably don't have memorized yet. Yeah. So sine of x times 1 plus cotangent squared is equal to what? Or x, right? Whatever the variable is. Are you seeing another substitution that might help us simplify this? What's the reciprocal of sine? So, I can write sine as 1 over the cosecant of x, right? And I can write cosecant squared over 1, which allows me to do what? No, there's no equal sign. We won't be cross-multiplying. I can just multiply, right? And if I have a cosecant squared over a cosecant, what does that simplify to? Right, if you can't see that, cosecant squared means cosecant of x times cosecant of x. I can cancel. Just get a plain old cosecant. I see why you have to have them memorized. The more that you do this, you have to do the homework, the more it's going to make sense. Okay? Experience is everything with these problems. Because certain problems are going to pop up a lot. You want to try another one? Everybody okay with that one? Simplify cosecant of x minus cosine of x times cotangent of x. What? This is going to simplify down to a single trig function. I'm just telling you that. Where do you think we should start here? That's a good thing. You're all staring. You're not sure what to do. I'll tell you what to do. If you have no idea what to do, the best thing is to start writing these things in terms of sine and cosine and see if you can start canceling things out. All right? So I see these two over here on the right. I got cosine and cotangent, right? Cosine I can write as over 1. What's the quotient identity for cotangent? What? Cosine over sine. Okay. How about cosecant? What's that? What's its reciprocal identity? 1 over sine. So what I have here is I have 1 over sine minus cosine times cosine is cosine squared. 1 times sine is sine. I have two fractions. Do they have the same denominator? Can I combine them then? That's no different than, say, 1/2 minus 5/2. Right? I can combine them. So I write the tops, 1 minus cosine squared of x over sine of x. common denominator. I see a squared. Anytime you see a 1 plus a squared, 1 minus a squared, or a squared plus a squared, or something like that, you need to start looking at your identities. Okay? Yes? What do you mean cancel out? We're just adding. If I said, what's 1/2 minus 5? Let's say I guess 5 halves. What would your answer be? Okay, that might be why you don't see this over here. All right, 1/2 minus 5 halves is negative 4 halves. How'd I get that? No. 1 minus 5 all over 2 is negative 4 halves, or negative 2. I mean, we can confirm it with a calculator if we need to, but that's how that works. Or if we were adding them, what's the difference? 1 plus 5, okay, which is 6 halves. So you didn't have to think about that one. 6 halves, okay. Or 3. Either way, that's the process, right? The 2 doesn't disappear. Okay, we just write it once. All right, so let's get back to the problem. We got to finish this. 1 minus cosine squared. I don't have that exactly on my sheet, right? It's not exactly the identity, but the trig identity. Okay, this is kind of like side work. This is what you should be thinking. Well, I have that identity. Can I make that identity turn into that? Sure. I'm going to subtract cosine squared. This is what I need, right? What's it equal to? So I replace it, or make the substitution of sine squared. You follow me there? Maybe color will help. That is that. Right? So I can make that substitution. I replace it with a sine squared. And again, I have sine squared over sine. We can write it out if we need to see it. Sine of x times sine of x all over sine of x. We get a simple sine of x. Any questions? Are you ready to try some homework, or would you like to see the answer? One more? Let me give you one more. Well, you want a more difficult one or an easier one? Both? You want the most difficult one? All right. I'll pick a doozy. See what we can come up with here. All right. All right. Okay, get it. That don't seem like fractions. Let me give you a fraction. Now, if I give you the odds, you'll know what the answers are, right? So here I'm going to give you the answer. That's what we want when we're done. That double fraction with all sorts of ugliness there is going to turn into just a little 2 cosecant of x. Ready to do it? Can't guarantee it's going to happen every time, but when you have 2 fractions, what do you think we're going to need to do? Combine. Okay? So let's combine them. We need to make the bottoms the same. So what common denominator are we going to use? Those are completely different things. That's like 3 and 4. That would be like 3 on this side, 4 on this side. If we have 2 completely different things, what do you do with those numbers usually to get a common denominator? Multiply them together. Make it 12 if it was 3 and 4, right? Well, we got to multiply these together. We can't, there's nothing in common about them. Okay, this term, this bottom is 1 plus, this is 1 minus cosine, so we have to include both of them. All right, we already have a sine of x on top here. What's new? What was not there before on this left side? 1 minus cosine of x. Whatever is new, we must repeat on the top of the fraction. Same over here. We had a sine of x. What's new? Good. Now can we combine them? Are the bottoms the same? Absolutely. When the bottoms are the same, you can add the fractions. Oops. All right. So my bottom is just going to be 1 plus cosine of x, 1 minus cosine of x. Top. I'm going to go ahead and distribute. So I got sine of x minus sine of x cosine of x, right? Plus sine of x plus sine of x cosine of x. Do you agree with that? What can we do at the top? And when we combine, I have a sine of x plus a sine of x, or 2 sine of x. That's a good thing, because we have a 2 in our answer, right? What about minus sine cosine plus sine cosine? They go away, more or less. When you combine them, they make 0. So that's gone. Now we've got to deal with this bottom. To save you some work, I'm going to give you a little hint, things you need to look for. Do you remember what we called these when we dealt with imaginaries? Remember the word we used? A plus bi and a minus bi. A minus bi was the conjugate. Conjugate, sound familiar? Are these conjugates? Is the only thing different the middle sign? That would be similar to an a plus bi, a minus bi. They're conjugates. When you have conjugates multiplied together, you want to FOIL them out because they're going to clean up very nicely. So let's FOIL this bottom out. 1 times 1 is 1. Outside is minus cosine of x. Inside is plus cosine of x. And your last is minus cosine squared of x. Remember how to FOIL? Yes? No? with numbers. How about if I said this? A plus B, A minus B. FOIL. You got your F, which is A squared, your O minus AB, your I plus AB, and your last minus B squared. So you end up with A squared minus B squared every time, difference of squares. If you can't remember FOIL, remember this guy loves the FOIL, Mr. Happy. We could put maybe like a hat on him or something. No? Too much? All right, sorry. You won't forget it, I'll tell you that. You'll never forget it. All right, so let's clean up the bottom. So we got 1 minus cosine squared of x. It's more or less what we ended up with over here when we did our simple FOIL. But I need some room. Why do I need some room? What do I have on the bottom? 1 minus something squared. Bells are ringing. Automatically, I should be looking at my Pythagorean identities. 1 plus something, 1 minus something squared. Side work. I think it's the same side work we just did in the last problem. This is what's in your head. I need a 1 minus cosine squared. Let's make it a 1 minus cosine squared. That's what I want. That's what it's equal to. That's what I'm going to replace it with. Now what can we do? What's left? Do I have to write this out? What can I do here? So I have 2 over sine of x, or 2 times 1 over the sine of x. Right? Can I write it like that? Can I put the 2 out front? Absolutely. What's 1 over sine of x equal to? What's the reciprocal of sine? Cosecant of x. By the way, 15 minutes ago, so I told you the answer. 2 cosecant of x. You wanted a doozy. That was probably one of the longest ones you're going to see. All right. Do we have any questions?